WiFi 都揾唔到你嗰個即係5G
我兩個都揾唔到。
你都揾唔到？
我應該揾到嘅。我呢個係 Accelerate WiFi。
WiFi 我揾到啦，但係揾唔到話 5G 嗰度。
哦，你揾唔到 5G？
係啊。
我先我拎咗。你試下 refresh 下個 network， 可能 airplane mode on， 跟住之後 off 翻。冇彈出嚟。
冇喎。
如果唔係就下低 naked student。naked
student 都唔見。
都冇啊？
係啊。
咁啊！
因為頭先都就 restart 過都係嗰個。
naked hub 嗰個好似係唔使密碼嘅，你試下。再唔係嘅話，要問下人。
You guys, are you able to log into the Wi-Fi here? Is everyone okay? Yes? Okay. You can't find it? Okay. I have to see. Okay.
因為頭先就我 connect 到佢WiFi 佢，但係就我想開 email 咧就當然唔到，咁我唔知係咪因為佢嗰啲 security block 咗，係啊。
呢個因為係
我做緊冇事冇用。
因為係連唔到 WiFi 係嘛？
係啦，咁就淨係 connect 到 WiFi，但係就唔見 5G 同埋 next student 嗰度。
哦，你應該呢部可能冇 5G 喎，但係你而家上到啊？
叫就上到，因為大就如果我想錄，我撳去開 email 咧，佢係 block 咗
block 咗。
係啊。
sorry。 we start, everyone? Okay. So shall we start? Okay. So today's class we're gonna be data analytics with Python, and we're gonna talk about data structure and pandas. So remember when in the first class I say the first week will be about coding, and then the next 2 weeks will be about data, and then the 3 weeks afterwards will be all about machine learning. Okay. So a structure today will be 3 parts again. So I'm gonna go through the homework that many of you have sent me. I'll sort of go through, well, not deeply, but go through everyone's work, and then I'll talk about structured data, like the importance about structured data, and lastly I'll talk about pandas, which is a powerful tools that using Python to handle or structurize unstructured data. Okay, so we're gonna start with Hangman, and then we'll talk about maximum substring. So I received like 7 or 8 Hangman, and what I'm happy with is there's no 2 identical answer. Doesn't mean you guys didn't copy online, so that's a good thing. Like in my previous class, half of the answers the same, so so they all copy from the same source.
So we don't know each other, right?
Okay. I've sent you the solution, Hangman solutions, in one of the workbook. So if you scroll through, there are a lot of answers, and they're ranked by how many lines they have. So I think, well, in general, the shorter the answer, the better the code is, because the code is cleaner. Okay. So in my opinion, this is the best answer. So let me do a survey first. Who guys struggle and can't finish the homework?
Just finish it.
Okay, just finish it. Okay. So do you guys understand the overall logic? Do I need to go through like step by step how to do it, or is it fine? Okay, if it's fine, then I'll just teach you how to screen through the code quickly, because I've screened through like 12 Hangman in the morning in 30 minutes. So the first thing is the structure. So if you scan through all the code, you'll see the structure overall is quite similar. So they have like a part that select the word randomly, and then everyone uses a while loop. Like while live, it's bigger than something and smaller than something. Then there's a logic that replace the word based on whether or not it's correct or not. So first thing is you see how many block of code you have. And if it's well structured, then we have 1 block, 2 block, and 3 blocks. Okay, and like this is another very good code, which is very clean as well. So you can clearly see there's a block of code in here and a if else. Okay, and okay, this one is quite good as well. So clear structure, 1 block, 2 block. And something that's less desirable, it's so-called a nested loop. Okay, so this one is slightly not as good as the other one, because you see you have 1 loop and you have the other loop, and then you have some if statement, and here's a for loop, and there's another if. So this is so-called a nested loop, and this makes the readability worse off. Okay. Remember in the first class we have this input this. Okay, so this is a poem by Python. Okay, Python is a very poetic language, so it has certain philosophy that you should follow. So beautiful is better than ugly. It means you have to write it elegantly. And explicit is better than implicit. This one is quite important because the naming of the variable has to be explicit. It means it has to be like self-explanatory. I'm sure when you guys work on this, you guys have a lot of variables flying around. And it's important that the variable is self-explanatory to you or to everyone else. Because I don't know if you have this feeling that when you look at your code, you understand everything. But when you try to look at other students' code, maybe it spent a long time figuring out what's going on. So it's important that you name your variable better. Okay, simple is better than complex. Don't write like complicated code. Flat is better than nested. That means the case like this is flat. You only have like one level, or let's say you can see it by the indentation. So this is like 3 level. But if you go to maybe this case, then you can see it's not as simple as the rest of them. Okay, and then we talked about readability as well. That's mean how other people can read your code clearly. And then okay, the rest of them are not that important compared to the rest. Okay. And I think by staring at other people's code, you can see, okay, someone can finish the entire program in 21 lines, while the longest would be like 53 lines. Okay, so yeah, I think it is a good practice that you have a look at other people's code and see how people do the same thing differently. Okay. Okay, any questions with Hangman for now? Okay, no questions. Okay, and then it's the maximum substring. I didn't receive a lot of answer for this. I think we only have 4 answers. Again, I think when you write code, always think or look for the simplest answer. It doesn't necessarily has to be the shortest number of line, but try to be as simple as possible. So this one's the one I wrote. So the question of this is, given a substring like this, okay, given a string like this, you have to find the substrings which has the highest sum. Okay, so the answer should be this, because the sum of it is 6. Okay, but the difficulty is you have to write a for loop that find out all the combinations. Okay, so it means you can't use one for loop to filter or to loop through the index, but you have to have 2 that loop from the beginning and the other one loop from the end. Okay, so if you run this and print aij, okay, then in this case a print will be very useful, because what my logic means is it loops through all the possible combination of this string. So start at -2, loop through everything, start at 1, loop through everything, and so on. Okay, and you can use this list comprehension to find the maximum out of all, and then return the one that equals to the maximum. Okay, does it make sense to everyone, or should I go through step by step? Step by step. Okay. Okay, so let's say I have to find. Okay, let's say this is an interview situation because this is an interview question. So okay, the first thing is I need to find out all the combinations. Okay, so I need to write a for loop that loop through the range. Okay, but I can't use. I have to use index because I have to loop it 2 times. Okay, so how should I write it? The first loop. So for I in range, length, and A, and in this case, if I put this, okay, I get something like this. Okay. But then I don't want to only loop it for 1 time, but I want to loop it for 2 times. So I do another loop, A plus 1. Okay, so now I don't only loop through I, but I only also loop through J. Okay, then I can do it this way. And if I print it out, I get something like this. Okay, because I don't. Okay, so this number, this index I, uses the loop outside, and this index J uses the loop inside. Okay. Any questions? Because this is the characteristic for this function. So if you put this, it's a range from 0 to 10. And if you count it 1, 2, 3, 4, 5, 6, 7, 8, 9, it's only 9. But if you do indexing, oops, sorry. Yeah. Okay. It starts from 0, and then it should go to A. Hold on. Okay. Because in Python, the range function doesn't count the last item of the list. Okay, so it has to be +1. Let me try. Lane. Okay. So if you do this for I, okay, I think you're right. I don't have to do +1. Okay. Sorry, I shouldn't do +1 in this case. Should be something like this. Okay. So any question for this step?
Well, you took +1. Because the last word should be 4 instead of -5.
Yeah, that's true. Okay, maybe for this I'll do some research and I'll get it back next time. Okay. And then, okay, after this, we want to find out on every one of these list, which one has the largest sum. Okay. Then I have to use an empty list to append it. Okay. So we have like a lot of lists, and you can do list comprehension. For I in I, if you do this, it's basically looping through all the element. But if you do this, okay, it gets all the sum. Okay, does everyone understand this step?
Mm-hmm.
Okay, so it's just looping through the list and get all the sum. And because this is now a list, you can just simply get the maximum. Okay, now we know the maximum possible combination. It's 6. Okay, then I called it something called M. Then all I need to do is, if the sum equals 6, that's the final answer. So I for I in L, if sum I equals 6. Okay, so that's the answer. If you want to write this line in the longer form, it basically means for I in L, if sum I equals M, then that's the answer. Okay? Any questions? Okay, if you guys want like to solve this kind of problem, I got like 2 more questions like this for you to practice. Or if you are not looking for a job, you are interviewing someone and you are lack of questions, I can show you some more of this interview questions later on. So the reason why I want you guys to do a hangman and the maximum sub array is because it uses a lot of loops. Okay, and it helps you to manage a lot of loop and manage like the entire functions. Okay. All right. So that's it for the homework, and let's go back to the class. Okay. So today we're gonna talk about data structure with Python. So what do you guys know about data structure? Have you guys used any sort of database or do any analysis using Excel for your work? Yeah. So Excel is the only thing you used.
SPSS.
SPSS. Anything else? Okay. Okay. So let me tell you like a little bit of what I've been doing. So one of my colleagues just went to hired by Facebook and went to US. So I've been looking at a lot of job advertisement. How many of you guys are hoping to look for a job in data science afterwards? Like being a data scientist? Yeah, one. How about the rest of you guys? You guys want to learn the skills to apply on your day job, or what's your motivation? Investment research. Okay, I see. So okay, I'll talk a little bit about like how to get a job in data science. So if you look through all the top data science jobs, they are all in like Facebook or Google. And if you look at the qualification, interestingly, a lot of them require a PhD. That filters like most of the people. But then if you search by the keyword data, so almost all of them involved working with a large and complex data sets. Okay. So what Google means by large and complex, it means a lot of them, like everything that matches your search results on the internet. That's the scales they're looking for. Okay, and that's not something we can process using Excel. Okay, if you go on to, let's say, well, another data science job, this one is more analytics and quantitative. It requires, again, a lot of data. Okay, large complex data, and it says non-routine analysis, means something out of the blue. It can be like not only text data, but with video and sounds and etc. Okay, and all these are data that you want to analyze and plug into like a data pipeline. It also requires you to know like R, SAS, and database. Okay, so as a data scientist, all you do is to build a model. But before you build a model, you have to structurize the data. Okay, that's why we have to spend 2 weeks learning how to structure data. Okay. Okay, so you can click onto this link, and it will bring you to a different notebook. Okay, it should work. Okay. Okay, so it talks about a lot of different type of data. So an Excel is a table, right? Okay, let's talk about the smallest data structure, which is a cell. Okay, one value, one variable that you defined on Python. That's the smallest unit. And when it grow bigger, that we have list, a lot of value. And when it grows even bigger, it becomes a table. Okay, which is what we're going to talk about today. A table with column and with rows. And if we grow even bigger than a table, what can it be? Like a 3D thingy. So nowadays they don't have like a 3D thingy, but they have something called XML. Anyone heard of what's an XML? Okay, XML is data structure, and we use it very often. So I don't know if you ever tried anything like this. So if you click on Chrome and then click Inspect, it will bring you to like a lot of HTML thingy. Okay, and you know in HTML you have like a tree structure. Like this is a parent and this is a child, and you have all this with so-called siblings. Okay, and if you store data in such formats, it doesn't have to be a table. So if one of the items have 2 siblings and the other one have no siblings, then you can still store it in a kind of structural way. Okay, so almost every huge data sets are stored in XML. Okay, and then after XML we have graph, and at last we have SQL. Anyone heard of SQL before? So what's a SQL?
It's a database that uses some queries that some analyze results will come up.
Yeah. But what kind of query do you use? Anything special with the query?
For example, in large database, for example, you request some what is the turnover of some specific customers.
Yes.
So, through SQL, and the whole query will come up.
I see. Do you ever merge 2 tables in SQL? Yeah, I think the most powerful thing with SQL is the power to merge different data sets. Okay, so SQL is a table. Okay, it uses table format. but it has something called the indexes. So you can merge the two data into one new table. So in that way, you can link a lot of different tables and combine them to make a new one. So SQL is a very powerful tool to store data. Right. How about after SQL? Does anyone know anything that's more powerful than SQL? How about if I have like the entire Walmart data to handle? What can I do? Okay, so if it goes beyond SQL, it will be in the enterprise level. So we have something called S3, which is something hosted by Amazon. Have anyone heard of Amazon AWS cloud service? Oh, sorry? Yeah. So this Amazon cloud service is something on the cloud. So Amazon built several different data centers in US or in Singapore, and then they lend you their storage space. Okay, and you can store stuff on S3. And if you do it that way, it's in a different scale, like 1 PB, which is 1,000 terabytes. Okay, and we also have something called BigQuery. Okay, this is my personal BigQuery dataset. So it looks something like this, but if you look at the number of rows, maybe not this one. Okay, it can store a lot of columns, and then if you go to details, okay, so it easily handles 83,000 number of rows, and this kind of things can handle up to 1 million or billion rows. Okay, so this is like the ultimate source of data structure. Okay. Okay. But today we're gonna talk a lot more about CS3. Anyone heard of CS3? Okay, so it's a comma separated file. Okay. So let's go back to our own workbook, and we're gonna work on the pandas question for now. So we're gonna work on one exercise first, which is the body mass index program. So everyone knows what's a BMI. So it's just the weight and the height, and you can find like a BMI of a healthy range of person. And in this exercise, we're gonna first use it without pandas, and then we'll try it with pandas. Okay. Okay, so we'll first of all set the random seeds to 3. Does everyone knows what's a random seed? Any clue? Yeah. So if everyone set the same random seeds, everyone gets the same random value. Okay, because there's no true random number in a computer. Okay. And then okay, here we will do something that we learned last lesson, which is NumPy stuff. So we set n equals 100, which is the number of people in the data sets. We randomly select people from the age group of 12 to 95. And then we get the height and weight from a uniform distribution. And then randomly select the gender. Okay. and we have something like this. Okay, and the height. Okay, then I have two functions that calculate the BMI given the weight and height. Okay, so if you do this weight and height, okay, if you do this function, it calculates the BMI for you, for everyone. Okay, and then okay, it kind of calculated quite quickly. But if you think of it this way, you have three lists. Okay, you have the BMI, and then which is a long list, and then you have the height, and then you have the weight. Right, it's not very handy to have three different separate things. Okay, and what would you do in this case? We have three lists with the same length. So what's a sensible thing to do? Combine them and make it a table. Okay. So that goes to pandas, which is the topic we're gonna cover today. So if you don't understand what's a pandas, I think this graph describes it pretty well. So imagine we have three lists. Okay, we have a list of height, we have a list of weight, and we have a list of BMI. So if I put the list perpendicularly and just combine them to make it a table, then we have a table of 3 columns and 100 rows. Okay, that's it. That's the whole concept of pandas. So make it a table.
Look if the list is not equal to length.
If the list is not equal the length, then you can't put it into a pandas. It has to be equal. Okay, so to use pandas, basically import pandas as PD, and then the most usual format is just PD data frame, and then you put BMI, and then height to height. Okay, then it becomes something like this. Okay, very handy, very similar to what we saw in an Excel, and you can also put this way, weight, okay. So for every data frame, we usually call it DF. So it's just a short form for data frame. Okay. And after you run it, if you want to select a column, you can simply use dot BMI, and it gives you the column. Or you can do it with like a square bracket and put the BMI in between. Okay. And then there are alternative way of selecting thing. But let's say you want to do selecting 2 columns. Okay, you simply do BMI and weight. Okay, in this way you only select 2 columns out of the entire 3 columns. Okay, and the other handy things with pandas is you can do many like statistics very quickly. Let's say you do df.shape. It gives you how many columns and rows are there. So 3 columns and 100 rows. Sorry. And then you can do dot describe. RIBE. Okay, if you do df.describe, it quickly gives you all the important statistics with the datasets. So, okay, how do a data scientist or a data analytics guy use pandas? So basically, for every new dataset, it just reads in using pandas. Okay, and then we'll just quickly go through some standard steps, which is find the description, see what's the average, mean, blah blah blah, or the data type. Okay, you can have I forgot how to do this. std. I think it's info. df.info. Okay, if you use df.info, it also tells you the data type. So now everything is a float, but it can go. You can put other data type like a string or integer inside the table, the data frame. Okay. Any question for now? Yes.
You mentioned, before you mentioned, you can select the different 2 rows out of 3 rows. What's the thing you mentioned first?
Okay. You mean this?
Yeah. Before mentioning this.
Okay. Before I talk about this one.
Yeah.
Before I talk about this one, I use this. If I want to select one column, I can do it this way, or I can do it this way. Okay. How about if I want to convert everything in height to inches, okay, or to cm? I can simply do this. Dot apply lambda x and then x times 100, and then I can do height in cm. If I do this, I can quickly create a new column in height. Okay, I will go through this apply later on, but I just want to quickly show you like how can you make the full use of pandas. Okay.
So basically, it's just Python version of Excel.
Yeah, it's very similar to Excel, but you know, in Excel, if you write a formula and you want to apply to everything, you have to like either scroll it down or just copy. But in this case, I think for 1, it minimizes the manual error, and for 2, is if it has a very huge data sets, it's very quick to calculate. While in Excel, it takes a very long time. And the third thing is, if you want to like cut off a subset of this, in Excel you have to do like filter and select the row and copy and paste. In here you can just do this. Let's say I only want the top 10 row. and with BMI and height only, I can do the head of it, top 10, then top 10 of it, and then I can do BMI and height. Okay. Or I can even do
How does this one decide what is top 10?
it's just
Chronological order.
okay. If you looked at the table, we have the index in here.
Yeah.
Okay, top 10 means from 0 to 10.
Oh.
Okay. And or you can even do like sampling, like find 10 random samples. Okay, this is just all the possible stuff that pandas can do. Okay, pandas is also very efficient in doing a time series. So if you want to do like financial stuff, use pandas helps you plot out the graph very easily, and you can see the trend very easily, especially in financial data. Okay, and also if you do like linear regression, you can simply plug in all the dependent variables and independent variables, and plug the entire data frame into the model, and it just runs everything for you. Okay, so just some highlight with pandas. It's super fast, a lot faster than Excel, and then it can read and write data very quickly as well. So at work, I extract the entire Walmart and entire Amazon, and basically everything that can handle by your memory can be read in pandas. So my CS3 is like 30 gigabytes, but I'm on a 60 gigabytes cloud server, so I can just open it on on the pandas. Okay. So okay, if you don't understand like Python data type versus a spreadsheet, this is a very good visualization of it. So in Python, we can like assign a value, x equals 1. On spreadsheet, it's something like one of the cells. Okay, and if we talk about list, it's just something like this on spreadsheet. And the data frame we talk about is something like this. So we have a fixed number of row for every list, and we combine them into a table format. And for your case, that if the list is not equal, then we can't put it into data frame. We have to put it into a dictionary. Okay. So a dictionary is something like this.
But will I be able to run panda on dictionary as well?
Well, you can still run it, but all these value will be so-called the missing value.
Mm-hmm.
And on the pandas, it will show as NA.
Okay.
And if you do like simple statistics, like find the mean of it, it will show the error. Yeah, because it's NA.
Okay.
But pandas is also very powerful in filling in missing value. So okay, let's imagine we're doing an experiment. Okay, we have collected 10,000 samples from pedestrian about their height. Okay, and we only collect the height sample and the sex sample. So it's either man or female. Okay, and in some cases there are missing value. So someone made an error and the value doesn't make sense. So if you are dealing with that data set, what are you going to do with those missing values?
Take out those data.
Yeah, you can take out those data, or there's one alternative way to do it. Yeah, you can fake it. Okay, how would you fake it? What's the sensible way of faking it?
Based on the percentage of your data, for example, it's male and female.
Yes.
See what percent in this data is male, what percent in this data is female.
Yeah.
And then try to make sense.
Yeah. So if what missing is a height, okay, what I would do is simply take the average of men, if the sex is men, and fill it by the average. Or if the missing value is the sex, then I can guess the sex based on the height, right? If it's very tall, if the sample is very tall, and I can assume that it's a guy. Or if it's very short, or it can be a very short man, but it's more likely to be a girl in that case. So I can just replace it with a girl. Okay. So that's a way for to remain a bigger data set without sacrificing the missing data. Okay.
So you mean pandas can do this job?
Yeah, pandas can do something like this.
If you substitute values like that, is there a way that you know that what values are substituted in pandas?
After you substitute it,
Yeah.
there's no way to look it back, unless you create like a before and after data sets. Okay, so you have the df before and df after, and you compare the two. Or you create a new column saying that something has been changed. Yeah. Okay. Okay, so for this table, it only shows you every row have an index. And what I meant by index is this. Okay, so on the very left hand side, there's a list of number. Okay, that number indicates which row and which column you're in. And in pandas, you can select by index. Okay, if you do df.ilog and you do like 1 1, it gives you the first. Oh, sorry. Okay, it gives you this number. If you put 0 0, it gives you this number. Okay, if you put a colon, it gives you the first row, first column. Okay, if you do it this way, okay, it gives you the first row. Okay, so this functionality allows you to cut off or dissect your data frame by will. Okay. Okay, so another good example for the advantage for pandas is a table like this. Okay, let's say you have initial pandas table, and based on your needs, you want to split it. Okay, in Excel, you have to like create a new sheet, blah blah blah, and in Python, you can just create three new variables. Okay, and you can do different stuff, and you can split it, combine it, or transform it very easily using pandas. So back in my previous job, I said I automate everything. So what I meant by that is I have some daily report or daily analysis about a football team. Okay, and then a lot of those analyses are repetitive. Okay, I do the same thing all the time. So if you have a pipeline like this, every time you split it the same way, you sum it the same way, and you can just automate, put it into code, run it, and generate some graph. And all you need to do is just look at the graph and make some judgment out of it. So pandas allow you to do this. But if you do it in Excel, you have to write macro, VBA, and It's not very efficient, it's not very elegant. Okay. Okay, let's go back to our previous example. So we have age, weight, and height. Okay. So here it does it a different way. So import pandas as PD. So you can create an empty data frame, like the empty list that we usually do. Oh, sorry. Okay, so now we have something called something like an empty data frame, and you can start creating a column by importing a list into the data frame. So what this line means is I import age into the column called age. Once I run it, okay, I have something like this. And if I input like weight equals weight, okay, then I have more columns. And if I run it everything, I have a new data frame. Okay. And okay, one thing to bear in mind is if you, after you put everything into a pandas, if you select one of the column, it looks like a list, but it's not a list. If you do type, okay, so-called the panda series. So it's again very similar to a list, but if you want to use it like a list, you have to specify it is a list, or else it looks a bit different. So it retains the index of your pandas table. Okay. So okay, again you can input the BMI, and okay, this is just a fancy function. Sorry, I have to run through everything.
Sorry, Patrick.
Yes.
Where does Panda get age data from?
Age data.
Sorry, I just couldn't find the one page already.
Okay, let me. Okay, hold on. Okay, I randomly created age.
Got it.
Okay. Okay, so this is just a fancy function that I have to run through the entire script to make sure I get everything. Okay, then I calculate the BMI, and I can start to do fancy stuff out of it, like run this body condition. If the BMI is lower than a certain number, I can say that guy is underweight, and if it's over a certain number, it's obese. Okay, and then I can add in such column. So in here I can calculate how many of them are underweight, or I can calculate how many of them are normal, that's between 18.5 and 25, how many of them are overweight, and how many of them are obese. Okay. But then this function is supposed to be df.pd. BMI. Sorry. Okay. If I put it this way, if I change it to underweight, and this is normal, and this is overweight, and this is obese. Okay, then if the BMI is 30, then it's obese. So if I apply all of this function into the BMI column, I can do it this way. So I either do the for loop that we always use, which is for I in df.bmi, because one of the column of the data frame acts like a list, so I can do it this way and put it into an empty list. Okay, then I have a lot of information about whether or not the person is obese or underweight, etc. Or alternatively, I can do it using an apply function. So apply function is very similar to a loop, which instead of using like for I in something, you just use lambda x, and x is the variable that you created to loop over. So if you use body condition x, and you create a new column called condition, okay, then I create something like this: BMI and a condition and a weight. And now if I want to do filtering, I can do condition equals obese. I made a wrong spelling. And if you do this, you filter out everything that is obese. And if you put not equal, dot condition. Okay, then you filter out everything that's not obese. Okay. Any question? Sorry. So if you do like conditioning in pandas, what's inside the square bracket is something looks like this. So it's a list of true and false. So if you use a bracket to bound this thingy and put df in front, logically it says every column that that is true shows up, and everything that is false does not show up. You can filter it this way.
Is this for Python or is it for Python?
I think for Python list it doesn't work. It works in a different language, like R. R works that way. But in Python, I don't think it works that way. But we can try. Okay. Okay, let's say you have a list of things like this. And then okay, now I have a different list. If I do this, I don't know if it works. Okay, it doesn't work. Okay, so it only applies on pandas. Does not apply on normal list. Okay. And let's say you want to do like double logic, like something happens at the same time, you can do this. So if statement condition equals not equals obese and the age is higher than 10, and you can filter out the much smaller data sets. Okay.
This may be a very stupid question.
Yes.
How would I know which function or which algorithm I put down that I won't change the raw data? How would I know what are the algorithm I put down that will change the raw data forever?
Okay. That's actually a very good question, I think. So okay, so we start with the raw data called df. Okay. Unless you have something like the equal sign.
Okay.
As long as you don't use the equal sign, nothing changes. So let's say I use df.apply. Okay, sorry. df dot. Okay, let's say I apply things on the age column. Okay, I transform the data. But because it wasn't saved back to the raw data, it didn't change anything. Unless I do this. Okay, in this case, I am creating a new value and I'm applying it back to the original data. So just remember, if you don't use the equal sign, nothing changes, usually. Okay. Any other questions for pandas? Okay. Okay, let's skip this one. Okay, I think this series is not very important as well. Okay, this one is more interesting. So let's say you create a series. Okay, this is sort of like a dictionary structure. Okay, you can put it into a series, and you create a series like this. And if you want to select special items on the series, you can do cities and Austin. And it's 450. Okay. So this is like a key indexing instead of having a number as the index. Okay. Let's skip to. Okay, this is more interesting. Let's skip to 4.2.1, which is the CSV extraction. Okay. So in this exercise, we have URL. Okay, this URL linked to your external CSV. If you put it onto a browser, it looks something like this. So this is the financial data with date, open, high, low, etc. Okay, and pandas. In pandas, you can directly read data from the URL. If you do, if you run the code. Okay, PD read CSV URL. It gives you the table. Okay. And I called the table called Tesla. And if you do past dates equals true, then the index become the date. Okay. And this is a stock price for Tesla. And if you plot it with the y-axis equals adjust close, okay, it just plot you the changes in stock price against the date. Okay. So yeah, this is very useful if you do like financial data to look at the trend. With the Tesla, you can quickly do the mean as well. So just select the closing and find the mean. Or you can describe the statistics. Okay. Okay, do you guys want to take a break? Like 10 minutes break?
Sure.
Okay.
Yes. When you say plot a graph over here,
Yes.
how does it define the distance between each? What do you call that?
Each date.
Each date, yes. Because there's so many data over here.
Yes.
And you didn't define anything over here.
Yeah. So in Matplotlib, I think it defines itself. So I think you can't change it.
I cannot change.
Or there's a parameter to change it. I need to search it.
Okay.
But usually it just adjusts it for itself.
But how does it define that?
Or define the axis.
Yeah.
Okay. So in this case, the index is date. If you don't define it, it automatically uses the index.
I see, okay. Yeah. And then, because it's for over here, you have like 21, 22nd, 23rd, 24th.
Yes.
So it's like day by day.
Yes.
But over here, it does not show. It's like every 2-3 days it's
Yes.
a spot.
Yes. It automatically finds the optimal range.
Oh, so it finds the optimal range.
Yeah.
And how does it define what is optimal? By the frame size? Or?
I think it's just defined by visually what can fit in.
Okay.
If this touches the other one, you just remove it. Yeah, but I think you can force it to appear.
Okay. And can I also define the size of the picture?
Yeah, you can. Hi. 有會㗎，可以 send 俾你。你係 SQL 定係 Mongo？
其實我仲想問，因為而家你呢邊係已經做高嘅，咁如果係從 SQL Server 嘅話，佢係一路有 connection 一路做一路掹嘅，定還是佢真係要入 low column？因為low column 我
佢個 logic 係將啲嘢搬入佢哋部機度，所以佢係要搬晒過嚟先做。
咁即係話，如果要佢可能嘈啲咁樣，即係可能其實都係要揀某啲方面先至。
有人公司機做，如果部機夠勁，我可以搬晒過。但係如果部機唔夠勁咧，最好係搬頭幾行先，揀晒啲 column 先至拎走咗嗰個 filter， 咁就會快啲。
部機夠勁嘅意思係？
其實係 RAM 嘅問題。如果你手機好勁啦都，
成爆 RAM 嘅喎。
你要用幾多個 row 嘅 data？
row
1000萬，咁真係會爆。
因為其實又唔係全部有用嘅，咁如果好似香港攞咗淨係有用嗰啲，即係可能失敗機就係失敗，Office 攞咗啲有用嘅地方，但係就攞晒落部機度先唔
SQL 有個特質咧，佢用個 key 嚟去 expand 嘅 table， 即係其實你可以係兩個好細嘅 table，merge 埋入邊個超大嘅 table。咁你唔好 merge 住，你將嗰兩個 row 嘅 table 搬入你部機先。 跟住用 pandas 嘅 merge。
即係差唔多自己呢個 build 一次所有嘅用過。
係，如果係咁樣標，如果你好多 table 嘅 merge。
污糟啊！
係啊，係啊。
唔係我 merge 嘅嗰啲就係好咯。
唔係，如果有啲 column 冇用嘅，唔好搬埋佢。
咁我如果即係因為咧，咁如果真係要啲即係已經揾一啲有用嘅 column，咁其實可能要每個 analysis 自己要再填翻一次，要啲乜嘢先至
或者都係 automate 嘅。你寫個 logic 係，咁你寫個 logic 話邊個用邊啲冇用？嗰啲咩？我唔知你班咩 analysis。
但係因為我如果要試，我一定要即係就係要知道點樣抗
應該會用。你係咪 MySQL 嘅？
唔係。
係 Microsoft。佢應該都係咁樣 connect 嘅。係啊。佢要打啲 server 名啊，個 connection 個 IP 啊，咁打落去就得㗎。我 send 條 link 俾你。
咧係咪都可以啲成
？XML 就
哦，
因為唔係 table，佢 show 唔到出嚟。XML 有第二樣嘢叫beautiful soup。beautiful soup，你就可以將 XML read 咗做 table format， 即係夾硬嚟，即係佢一個 cell 入邊再有啲分支嘅。
但係 XML 點變咗？
佢可以咁樣嘅，揾翻啲。
都係用 pen，唔係用 pen。
係用 pandas 㗎，即係當你個 structure 係咁樣啦。可以咁樣，即係佢呢度咧，唔係一個 value 嚟嘅，而係一個 list 嚟。或者你入邊咧可以係乜都得嘅，你入邊係一個 dictionary 都得嘅。當咁樣，佢就會咁樣 show 出嚟，咁你就可以夾硬 read 佢入去。
但係你完之後都好難另一條要變呢啲 data，即係
係
可能
㗎，
嗰個 type 唔一樣，你好難。
係好難做 model
啊嘛，
你可以夾硬 read 入去先，
嚇，
跟住再諗點樣搞。你可以喺入邊 create 多個 column 出嚟，即係如果佢哋係，你知道要揀邊個 field。係。
但係
大家有。哦，因為大世界係關事。
其實啱啱講下啲 logic 係點解呢條 square bracket 即係呢個咩意思？加到呢個
基本上咧，
因為其實係因為佢嘅啲 logic 係開得成一個啱啱唔記得咗，因為有啲係即係有啲同之前嗰啲 code 有少少。
可以講
因為有陣時有 DF 同 DF 嗰啲特別有陣時係佢真係幾似嘅，係咯，即係佢個 code 就係咁樣就 add 咗個 code 係 add 咗個你話啦
係
跟住係咯，點解係咯，即係點解有呢個等級係咯，即係我想睇下
咁嗰個即係講一啲最易記咧，就係 square bracket，一定係 index。即係 square bracket 係永遠都係討論嘅啲關於位置嘅。咁如果你咁樣入邊嘅嘢咧，一定係令到佢即係揀咗佢入邊其中一個位嘅嘢。咁咧為咗方便咧，如果你打 string， 佢又會自動揾一個 column， 即係佢就會揀咗一個 column 嗰個位置。咁咧，但係咧，如果入邊係一個 logic， 所謂 logic 咧就係啲 binary 嘅嘢。如果係 BMI 大過20，佢咪整咗啲咁嘅嘢出嚟。
係咧，因為有啲情況就唔多咁樣，有啲情況即係 square bracket 就係 OK 一嚿嘢。
你可以咁樣嘅 square bracket locate 咗 BMI，
係。
咁我一撳咧就撳一個 list 出嚟。
係啊。
咁我想揾呢個 list 邊啲大過20啊？咁我就將佢變咗做 true and false。
哦。
但我而家跟住我喺呢一刻，我想揾個位置，因為如果我 filter 你就揾個位置。咁好啦，咁我 square bracket。咁但我想揾咩位置咧？我係想揾呢個 show 出嚟嘅位置，就係 BMI 要大過20。咁我哋將成嚿嘢擺入去。咁我就揾一啲位置出嚟 ，which is 呢個。即係你
呢個冇 K 意思。
係啊。
Doc 就係 logic。
多其實好 tricky 嘅呢個，佢多咧其實方便你嘅，方便你可以咁樣好快嘅。
係，一時。
係啊，所以如果你覺得 confuse 咧，你唔好理佢多，即係永遠都用，永遠都用 bracket。
但我想問呢個情況就係Lambda 呢一個其實係佢 add 咗個 new column 就等於呢嚿嘢。因為我想知係如果即係用 pandas 去一個 table 就 add 一個 new column 係將DF 跟住 square bracket 個名即係同一嚿。係之前即係呢個就係一個 logic，就之前大家成日整出嚟，即係你話好深學咁樣。嗰個就係一個 new